Namaskar Mitrano. Today we are going to learn how the alternating current gets generated. Okay, so you know the laws of electromagnetic induction, that is Faraday's laws of electromagnetic induction. If there is a magnetic field available and if we move any conductor in that field, then the EMF is getting induced in that conductor. Okay, at the end of that conductor, if you take the end points of the conductor, we will get the voltage, and we apply any load to that conductor, naturally current will start flowing. Faraday's law of electromagnetic induction is a basic of your AC circuit or principle of generation. Okay, so here we are representing this north and south pole. The magnetic lines of force are starting from N and ending on S. This is one turn of a coil which I am rotating in the anti-clockwise direction in the field. So it follows the basic sine waveform. Okay, so whatever voltage is getting generated in the coil is directly proportional to the angle between the coil and the lines of magnetic force. So that angle is represented by theta over here. So V is directly proportional to sine theta, or you can write V is directly proportional to sine theta. And in equation form we can write V is equal to Vm sin theta, where Vm is the maximum value attained by that voltage. Okay, so for every different instant, suppose theta is equal to 0 degree, we will get V is equal to Vm sin 0. So value will be, instantaneous value of that voltage will be 0. At theta is equal to 90 degree, V is equal to Vm, because sin theta becomes sin 90 and that gives me 1. Okay, so this is the maximum value I can attain. V is equal to Vm. So this is that point, pi by 2. Okay, then at theta is equal to 180 degree, we will get instantaneous value V is equal to Vm sin 180. That will be 0, because sin 180 is 0. See, small b represents the instantaneous value of that voltage. Okay, at any instant, 0, 10 degree, 20 degree, 30 degree, like that. Okay, so again, if we move ahead, theta is equal to 270 degree, this is the point, we will get instantaneous value as minus Vm, because sin 270 will give me minus 1. And then theta is equal to 360, again we will get instantaneous value of voltage is 0. So if you plot the graph of this, taking intermediate values also, here we have to take the intermediate values, so we will get pure sine wave. And that's why the standard form of sine quantity is given by V is equal to Vm sin theta. For current you can write I is equal to Im sin theta. Here I am writing for voltage V is equal to Vm sin theta. If omega is the angular velocity of rotation of this coil, then the theta can be written as theta is equal to omega t, and therefore your second equation or second standard form will be V is equal to Vm sin omega t. Instead of theta, the omega t is coming over here. Now what is omega? Omega is angular velocity, so its value is given by 2 pi into f. Omega is given by 2 pi into f, and that's why I am replacing omega with 2 pi f in my third equation. So this is my first equation, second equation, third equation. So I will get V is equal to Vm sin 2 pi f into t. But what is f now? F is reciprocal of the time period. So f can be replaced by 1 by t, and therefore in the fourth equation I am replacing this frequency with 1 by t, and therefore the fourth equation will become V is equal to Vm sin 2 pi t divided by t. So these are the four standard equations we have to use while solving the numericals. Similarly, you can write for current I is equal to Im sin theta, I is equal to Im sin omega t, I is equal to Im sin 2 pi f t, and I is equal to Im sin 2 pi f small t upon capital T. So for this video we will stop here. Thank you.